to all. Now we are heading towards the day 2 of the master training. We are now proceeding to the first technical session, that is an overview of packaging, recent packaging technique to extend the shelf life of the product. Dear participants, if you have any question during the presentation, please type them into the chat box. We will bring up them after the end of the session. Now, without further delay, we will proceed to the first technical session. For this session, we have with us Dr. S. Ananda Kumar, sir, Associate Professor and Head of Department of Food Packaging and Sensory Department, NIFTM Thanjavur. I would quickly like to introduce sir to you. Prior joining to the NIFTM Thanjavur, he has served as an Assistant Professor in the Department of Marine Technology in the College of Marine Science and Technology in Northeast Africa. He has more than 15 years of experience in teaching and research, also specialized in designing of food processing equipment and development of sustainable food packaging material. He has developed many processing technologies and equipments such as continuous type counter current foam mat dryer, solar pack bed dryer, and many more. I welcome you, sir, in this and thank you for accepting our invitation. The session is over to you, sir. Thank you.
Thank you very much. Is my slide is visible and I am audible?
Yes, sir. Your slide is visible. Can you put in a slideshow mode? Yes, sir.
Thank you very much. Good morning, Professor, in the meeting. I have seen there are many people in the academicians and research institute. This morning session is this general topic regarding the packaging. For examples, if you take any particular sector, either it can be fruits and vegetables or dairy or spice processing or cereal, there are some certain limitations or certain packaging materials are used in particular purpose. So here I can tell you what are the recent advances or what are the standards we are following in the food packaging applications. What kind of machineries are used for the bulk packaging as well as the unit packaging. So you will get overall idea about the current scenario in the packaging technology. And if you have any specific doubt on any particular area, so that you can tell us in the chat box or something, so that we can address at the end of the session. This lecture is about advances in food packaging for enhancing the safety and quality of the products. So when we come to the packaging common definitions, we can say any valuable commodity it is covered or enwrapped into some physical material. Either it can be a plastic covers, paper or glass bottles or metal cans. So this valuable commodity can be covered with some physical material that will support to protect the food items from different environmental factors until it reaches the consumers. That action should be called packaging. So there is a terminology, packing and packaging. When we say the packaging, that includes the science as well as the engineering support. For examples, when we talk about the science, particularly relevant with the food applications, because nowadays you can see there are migration studies are taking place. For example, from the plastic bottles, some bisphenol A, B, C components can be migrated from the plastics to the food items. Otherwise, if you take the metal containers, some tin contents which can be leach out from the metal can surfaces to the food items. So in such a case, that the chemical interactions between the packaging materials and as well as the food items, you must know, so that you can understand what kind of packaging material suitable for particular products. So the science background is important. And another thing, engineering technology, that is also important when we talk about the packaging technology, because we have the classification of the packaging like primary, secondary, tertiary packaging material. Either the packaging materials, it can be used for some handling purpose or it can be used for some transportation purpose. So in such a case, what is the strength of the packaging material? What will be the barrier properties related to the gases and moisture? So those things you must understand when you develop the packaging film for the mass productions, particularly in the industrial production stage. So you must have knowledge on the engineering aspect, so that that will help you to make such a polymer and which can be produced in the larger quantities. That is also very important. So when we say that packaging, so it's an art of science and engineering technology joined together to make a convenient packaging material for the food applications. So in mainly when we talk about the food, so these food items we have the category such as like perishable, highly perishable, and the shelf-stable commodity. For example, there are some food items it can be stayed in the normal atmosphere for 6 months or 1 year also. For if you take rice, dal, it can be stayed in the normal atmosphere. So we don't want any hi-fi packaging materials or technology for packing those commodities. So only the thing is, if you control the environment and if you control the insect infestation in the storage area, so the product can be stayed for longer period. So such a food item which will be called a shelf-stable commodity. And apart from that, we have perishable and highly perishable commodity. If you take the fruits and vegetables, which becomes perishable commodity. If you take meat, fish, okay, that will come highly perishable. So whenever you go for perishable and highly perishable commodity, then you must know what will be the barrier properties of those packaging material and what will be the temperature, particularly the frozen products for meat and fish. You will keep the product at minus 23 degrees centigrade or minus 40 degrees centigrade. So under these conditions, the packaging material should not be affected by keeping the product at lower temperature. At the same time, the barrier property should not be go down in terms of maintaining the quality. So in such a case, these things are very common when we go for selecting the appropriate packaging material. So when we say the major functions of these packaging materials, why we are going, so one is that containment. For examples, we have different capacity. The buyers, consumers, if you see, there are different buying capacity. They have, for examples, some people they will buy half kg, 1 kg, 5 kg, 15 kg. So according to the consumer demands, when you want to give the product, so the packaging material only will support as per the consumer demand. We can make convenient packaging in this particular sizes. And another things, the protections, as I told you, the biotic and abiotic factors, human environment, all these things which will have immediate reactions with the food items when it is exposed to the different environmental condition. So in such a case, this packaging material, it has to protect the food items from all these kinds of environmental aspects. For example, if you take the milk powder. Okay, so the milk powder, the moisture content, for example, is less than 7% or 5%. So this milk powder, it is hygroscopic in nature. So whenever it is coming out from the packet, once you open the packet, so what will happen? The moisture absorptions will be taking place. So that what will happen? The free flowing powder will be converted into in the form of cakes. So once the moisture accumulated, that will attract the fungal growth, okay, the bacterial contamination, all these things. So when we talk about the milk powder, so we should have a material that should not allow the outside moisture to enter inside. So that is the things we are following. In another case, if you take some milk product, some paneer or something, or else if you take some meat product, so the meat items or the paneer will have some moisture content. Okay. So if the moisture content goes out from the package, what will happen? It will become dry. So that time weight loss will come and you will not get the particular sensory appeal of in the product when we use it. So in the second case, the inner moisture should not go outside. So in both the cases, you have to select the packaging material will have high barrier for the moisture, so that you can control the quality changes during the storage period. So that is very important. And another thing, if you see, in the beginning when the packaging started, it was, for example, during the Second World War and so on, so that time. So what we will do, we will pack the product first in the packaging material, then we will go for processing. For example, if you take the canning, so what we will do, we will fill the product in the canned material, then we will go for retarding process. But now it is different. Now first we are processing the product, and next we are coming to the packaging. For example, ultra high temperature processing. So UHT process, you will process the milk, then you will fill into the aseptic condition, you will pack the product. So in such a case, that ready to eat, ready to cook products are getting more popular in the current scenario. So in such a case, these products, when you want to preserve it, so only the thing is selecting the proper packaging and the storage conditions which will support. And another thing, communications, as you know, the labels are very, very important. Okay, even FSSAI now they have the labeling section separately. Initially, it was packaging and labeling section. In FSSAI, it was the same panel, but now they made it separately because there are many advancements are coming in the labeling section itself. Even you can see that the front and back labeling sections are coming, because when the people buying the product, they must understand what will be the fat or what will be the protein, carbohydrate content available in this product, so that as per the health requirement, they can select the product in the market. So these are all things are coming. So communication is another function which can be done. And the convenience packaging, for example, resealable, reusable packaging material. Even some of the countries, when we want to export the commodity, now many countries, they are minimizing the imported quality if it is packed with the plastic packaging materials, and they are requesting us, the exporting country, if it is any sustainable packaging material, so that can be recommended for packing such a food item. So like that, making environmental friendly, okay, convenient to the consumers. So all these requirements are coming in the current packaging usage. So in such a case, many R&D are also taking place in the development of sustainable packaging material. In the industry, if you see any food processing industries, the packaging sections will be the last unit operations. For example, starting from collection of the raw materials to the processing, then packaging. So packaging will be the last unit operations. But if you see the consumer point of view, so the packaging will be the first preference for selecting the food commodity. So what kind of the branding you are using, what kind of the labeling, or what kind of the display you are using in the packaging materials. Okay, so that makes more attractive to the consumer to select the food item. So packaging is very, very, very important in the consumer point of view, and for the industry point of view, to enhance the quality or maintain the nutritional value of this product. So packaging in both the cases, industry and consumer, is very, very important. And another thing, the packaging, it is not new. For example, some of the literature says before 7,000 BC, otherwise almost 10,000 years, we are using different kinds of packaging materials for the food application as well as the storage purpose, starting from the Stone Age to the current bioplastic utilization area. There are many packaging materials we are using it, and this packaging technology we are learning from the nature only. Even if you see any living things, okay, so it has a very good packaging systems. So that is why we are all very safe in the earth. So in such a case, you take any pulses, you take any foods or cereals, even human being, animals, will have a very good packaging system. So that is why we are all surviving very well. So in such a case, whenever we want to extend the life of the product, whenever in our human being will say the life of the people in food items will say shelf life of the product. So whenever you want to extend the shelf life of the product, in such a case, the proper packaging material should be selected. So in such a case, you can expect or you can increase the shelf life of this commodity. For example, you can take some food items. A good example, you take some carbonated beverages. You take some Sprite or Pepsi. Okay, so this type of any carbonated beverages you take, it is also available in different kinds of packaging material. It is available in metal cans, it is available in glass bottle, it is available in PET bottles. But if you see the shelf life, if you check the labels, the shelf life of this commodity will be varying because individual commodity will have different kinds of these barrier properties, gas retention properties. So in such a case, automatically what will happen? The life extensions also will be varying according to the selection of the packaging material. So whenever you want to extend the commodity shelf life, so in such a case, you should have a selection of appropriate packaging materials. In coming to the basics of this packaging, we have that primary, secondary, and transit methods of packaging we have. So when we say the primary packaging, the food items will have a direct contact with the food materials. That is called primary packaging material. So whenever you select this primary packaging material, it should be a food grade packaging materials. So when we say the food grade packaging materials, for example, if you see the FSSAI document packaging and labeling, so 2018, so they given food grade packaging material. It is developed by using that BIS standard. For example, if you take food grade polyethylene packaging material, food grade polyethylene terephthalate packaging materials, they given IS standard 10,143 or 10,156. The number has been given. So when we see the standard, they given when it is a food grade packaging materials for the PET bottle or when it is food grade packaging material for the polyethylene. So they mentioned what are all the filler materials it should be added, what are all the resin should be added, what kind of coloring material should be added when we prepare the master batch during the production of these different kinds of packaging materials. And also you can see sometimes this ethylenyl acetate, or when we say some of the packaging material that bisphenol A will be added. So these are all the components when it is starting migrating from the packaging material to the food items, so it will cause different kinds of health issues. So in this case, the packaging material which can be used for the engineering applications, the packaging material which can be used for the food applications, it has differences. So always when we select that primary packaging material, it should be a food grade packaging material. And the second thing, we have that secondary packaging material, for example, corrugated boxes, we have plastic grades, wooden boxes. So all these things which will be called the secondary packaging material. And when we say the secondary packaging materials, we will see the number of plies, number of layers, okay, the number of fruits, what it is having in the corrugated boxes, what is the strength of that packaging materials in terms of hardness or in terms of tensile, compressibility, all these things you will check because it is used in the handling and transportation, this secondary packaging material. And another thing, the transit packaging material. So this is bigger in size and which includes many number of primary and secondary packed food items, mainly when we go for transporting the commodity from one country to another country or one state to another state through the ship or through the air. So we will use this type of bigger size of packaging material. So in this case, mainly the strength of the packaging material and the packaging material interaction with the environment, it is very, very important. For example, the peoples, they will ship the onion through the ship in a bigger cargoes. So in such a case, when we transport the material through the sea, okay, the relative humidity, okay, the moisture content in the ambient, or the temperature, all these things which can easily affect the quality of the product during the transportation, in the holding time or the resistance. So in such a case, this packaging material, okay, that will not give over transfer of the heat or that will not should not allow that over humidity increase in the chamber so that it can avoid controlling of that is sprouting or browning reactions, all these things. So in such a case, the strength of the packaging materials is very, very important when you go for transit packaging process. In general, there are 4 packaging materials we are using in the food packing applications. Namely, we can say the glass bottle, plastic containers, metal cans, as well as the carton boxes. Apart from that, there may be a combination for glass bottle with the plastic liner, or else laminated plastic materials, or metallized polyethylene film, or metallized packaging material, retard packaging materials, increasing the number of layers. So, like that, we have different combinations of these materials for making a new or novel packaging material that can support or which can be used in the packing of a young product. So individual packaging material, if you see that the glass bottle, plastics or metal cans or corrugated boxes, each packaging materials will have their own advantages and limitations also. For example, if you take the glass bottles, the melting point of the glass bottle, it is almost 1300 degrees centigrade or 1500 degrees centigrade. So this material in our food applications, when we go for retarding, so the maximum temperature we can go up to 121.1 degrees centigrade. So in this case, the glass bottles will not be having any interactions chemically with the food items, because the melting point also it is very high, 1300, 1500. So that glass bottle in general we will say it is a inert material. There will not be any chemical reactions, and it will have more thickness or barrier for the food items from the environment. So these are all the advantages. Even sometimes if you see the transparent glass bottle will have color changes in the product, you can have the amber glass bottle, colored glass bottle, that also you can make. So in such a case, glass bottle is very safe for keeping the food items. But in the other side, if you see the limitations or disadvantages, the tensile strength of the glass bottle is very less, okay, almost nil, zero. So even a small extension in the tensile, that will cause breakage, mishandling will cause breakage, cost of the packaging materials will be high when compared to other kinds of packaging materials, and the empty weight of the glass bottle is high when compared to plastic or metallized film or metal cans. So this will add cost to the industry people when they want to ship the commodity from one country to another country or one state to another state. The transportation cost will be increased when we go for using this glass bottle. And another advantage, it can be recyclable. N number of times you can collect the waste bottle, you can go for recycling. So like that, individual packaging material, plastic cans, carton, if you take individually, it has the advantages and the limitations also as per the industrial application usage or the cost of the packaging materials. You can select appropriate packaging materials for your goods, what you are preparing. So that can be supportive for the economically industrial persons also and the consumers. This is the one example just I want to tell you. Here the product is same, mango juice, it is the same. But if you see the packaging material, what we are using, it is different. Okay, either it can be a Tetra Pak, or it can be a plastic bottle, or it can be a metal containers or glass bottle. But same juice items, it is packed in different kinds of packaging material. Even you can see same industry will make different kinds of packing the different kinds of packaging material. So here we will first classify according to the packaging standard. For examples, we will classify the food items. Either it can be a ready to serve RTS product, or ready to drink or ready to eat RTE product. When we say ready to serve, the packaging size is very high. For example, 2-liter fruit juice or 1-liter fruit juice, it is called ready to serve. For example, we have some friends get together party, or in the home we have some get together party. So we will not buy individual packet. We will buy for example 1-liter, 2-liter. So this materials which will be called ready to serve packaging. In such a case, that 1-liter or 2-liter packets in the Tetra Pak or plastic containers we are purchasing. And these materials are take-home material. Okay, you can pay and you can take the materials to your home. So in such a case, when you buy this product, the packaging material cost also will be added in the product. Okay, but in case of if you see the glass bottle, for example, after drinking the juices, you will return the bottle to the shop. So So in such a case, the glass bottle cost will not be added in the product cost. For example, that individual glass bottle may be 25 rupees. Along with the juice, it may come some 50 rupees, but they will charge only 15 rupees for the juice only. So in such a case, the packaging material cost will not be added. But in the first two cases, the packaging material cost also will be added in the product cost. And the last one, it is a metal containers. So that is also take home material. So there also, if you see, the cost of the metal cans will be added in the product. And another thing, if you see the shelf life of this commodity, so this Tetra Pak, they will give 6 months to 9 months. If you see the PET bottle, they will give only the 6 months. And if you see the glass bottle, they will give only 3 months. If you see the metal cans, they will give 9 months. So the same juice, but according to the packaging system, the shelf life also will be varying. And another thing, you can have the cost of the packaging materials. If you see the Tetra Pak, for 1 liter or 2 liter, the cost of the packaging material, it will come something like 50 rupees or 12 rupees. PET bottle, you may get some 7 rupees. Okay, the glass bottle is different, and the tin containers also it is different. For example, 7 to 9 rupees it will come. So in such a case, the cost of packaging materials also will be varying. So you can think when we go for selecting the packaging materials, one is the cost of the packaging materials, and the second thing is the shelf life. What is the shelf life? And where it can be used, either it can be ready to serve or ready to drink. So these are all the criteria you have to consider when we go for selecting the appropriate packaging material for your end use purpose. And when we say the different kinds of packaging materials, for example, majority of the foods what we are packing, for example, globally, the highest packaging material what we are using in the food application, it is there paper-based materials. 60% of the packaging materials what we use, it is a paper-based material. But when we talk about that primary packaging material, so that plastics are highly used in the food applications. Even if you see any countries, what they are producing the packaging material, majority of the packaging materials which can be used in the food application, particularly if you take in India, what is the plastics we are producing in our country, in that 40 to 45% of the plastics we are using in the food applications only. In the packaging material of the plastics, we have two categories. One is flexible packaging material and another one is the rigid plastic containers. Okay, the flexible packaging materials will have the film forming properties. Will be having either it can be used in the vacuum packaging, it can be used in the shrink wrapping, okay, or it can be used in the MAP gas flushing unit. So these type of things will be called as a flexible packaging material, having the thickness or the size of the packaging material will be varying from some 5 micron meter to up to we can say some 250 micron meter, 300 micron meter. For example, 200 gauge or 300 gauge thickness packaging materials are also available. For example, if the thickness is increasing around above some 250 or 300 micron meter, it will become a rigid plastic container like a PET bottle or polyethylene, high density polyethylene bottle that can be used in the different applications. So in such a case, these flexible packaging materials are used in the packaging of grocery material, fruits and vegetables, spice powder, milk product. In all the cases, the flexible packaging materials are highly used, and this can be produced in the industry by using axial blown method or casting method. Even sometimes, for example, if you want to pack the fruits and vegetables, all these commodity will have the respiration characteristics. Under these conditions, there are what we can say the micro perforated bags are coming in the market. For example, by using laser beam technology, a small micro holes can be created on the packaging material. So when we pack fruits and vegetables, that can be act as a breathable packaging material, so that will not keep a higher amount of carbon dioxide inside the package, which will diffuse through the packaging material, so that the shelf life of the commodity can be extended. Okay, so this is a flexible packaging material. Even you can see nowadays that resellable packaging materials are also coming in the market. Okay, with the pouches, and there are different forms of flexible packaging materials are available in the market. For example, you can see the pillow pouch material, stand-up pouch material, Okay, otherwise that four-side sealing material, three-side sealing materials. Okay, like that, based on the sealing characteristics or sealing properties, otherwise the shape, otherwise the size of this packaging material. Okay, it is varying in different size and different shapes. So these are all the packaging materials. It is used to particularly in the ready to eat or ready to cook food items. Even sometimes, for examples, if you see some of the packaging material which can be used in the modified atmosphere packaging. So in such a case, that monolayer materials that will not support you to retain the gases inside the package. So in such a case, we will go for a laminated pouches or metallized pouches for keeping the gases inside the packaging materials. Otherwise, for improving the barrier properties of the gas diffusion or moisture diffusions, multi-layer materials can be joined together to make such a stand-up pouches or else the pillow pouches. So these packaging materials, it is also available with the see-through windows. For examples, if you take this type of that extruded product, okay, the see-through windows are available. So in such a case, one side you can have the printing in opposite, and the other side you can see the product visibility, so that that can interact with the consumers to know about the appearance of the product, and that makes the attraction to the consumer to buy such a product. Even you can see there are some packaging materials you can have that is stand-up pouch material. For example, some of the juice industry, that fruit essence with the different flavors can be joined together in a single packet. And when you want to prepare the any juices, so that can be separated and it can be prepared separately in the different volume. So this type of things can be easily made. That the formation of different sizes or the different layers can be made in the plastic packaging materials. And another thing, we have the rigid plastic containers. As I told you, the thickness of the packaging materials about 250 to 300 micrometers. So this we call as a rigid plastic containers, and this is made by using a thermoforming method. So either it can be a plug assist method or vacuum trapping method. Okay, so this type of rigid containers or thermoformed containers are formed. So these type of materials that can be used for packing of the processed food items, particularly if you see the seafood, red meat, fruits and vegetables, okay, dairy product, in all these cases, ready to eat food items. So all these things, it can be packed in a rigid container, so that that can support you the materials, food items during the transportation, avoid the mechanical damages. Otherwise, that can improve the barrier properties, so that the interaction with the environment can be minimized. So all these things, it can be done by making such rigid plastic containers in the food applications. In general, particularly when we say the plastics, there are 7 plastics we are using in the food applications. For example, this in a triangle symbol, if you see these numbers, okay, that recycling inside, if you see the number, that indicates the particular plastic material. For example, the number 1 indicates polyethylene terephthalate. So this polyethylene terephthalate can be used in the packaging of carbonated beverages. It has very good puncture resistance. It has very good glossness. It can support you the printing also. So in such a case, this polyethylene terephthalate, it is used in the packaging of edible oil, packaging of flavored milk, packaging of carbonated beverages. Even if you take that fried nuts or something, if you want to pack it in the flexible packaging material, so the polyethylene terephthalate also one of the layer which can be used in the laminated pouches. So these are all the things you can consider. Number 1 will be a polyethylene terephthalate, and the number 2 is high density polyethylene. Okay, this polyethylene, for example, this oil cans or water milk cans, okay, 1 liter milk cans, it is made by high density polyethylene. Even if you see some of the sausage, chili sausage, tomato sausage, okay, so all this sausage product, or also it is packed in the high density polyethylene. It has the flexibility, and also the density value of this polyethylene can be above 940 kg per meter cube. So based on the density, we have LDP, HDP, and medium high density polyethylene, medium density polyethylene. So these type of materials are also used in the processed food items. And another thing, PVC, polyvinyl chloride. Okay, number 3. So this is also used and it is crystal clear like our PVC pipes. So that can be made by heating and cooling of the product. And this also will have the good barrier for the moisture and the gases. Particularly if you see the blister packaging, the pharmaceutical products, or if you take that the chewing gum or something, okay, the chiclets or the confectionery product which comes in the blister packaging. The top layer is made by the PVC material. And another thing, low density polyethylene. Okay, particularly if you see the milk packets, okay, 10 rupees milk packet, it is made by LDPE combined with the LLDPE. Otherwise, you can have some of the liner material. For example, we have paper-based packaging material or retard packaging. If you say multi-layers will be there, their inner material will be the low density polyethylene because it will have very good sealing properties, LDPE materials. Apart from that, we are using these covers in the packing of bakery product, particularly bread. Okay, that can be packed in a flexible packaging material. So number 4 indicates LDPE, low density polyethylene. Then we have polypropylene. Particularly, you have all grocery items are packed in a polypropylene cover because it has more transparency when compared to polyethylene. And also similarly, it has the similar kinds of gas barrier and moisture barrier with the polyethylene properties. And another thing, it can be made like a flexible packaging material as well as a rigid container. That rigid containers that can be used in the packaging of the dairy product, yogurt, it can be packed in some of the ice creams, it is ice creams, it is packed in small cups, polypropylene cups. And apart from that, food trays are made by the polypropylene. So this is denoted by number 5 and the polystyrene, that is thermocol. So it is number 6, particularly to make thermal insulation in the food applications or transportations, we are using this thermocol material. But now many packaging industry, they minimize some of the industry they stop usage of that polystyrene in the food applications. But particularly for transportation of the fruits and vegetables to give the cushioning effect to avoid the mechanical damages in the fruits and vegetables. So high value commodity. Okay, so that can be covered with the expanded polystyrene foam material, so that can avoid the mechanical damages during the transportation. And number 7, okay, as I told you, there are 7 plastics we are using it. So number 7, it is not a monolayer materials. For example, before what we have seen, it is a particular plastic, either polyethylene, polypropylene, okay, otherwise PVC. All these things are individual polymer. But here, if you see this, when we say others, it is a multi-layer material or co-extruded plastic material. So in such a case, whenever you have ultra-processed food items, so these food items, it can be affected very quickly because there are many chances for the interaction of these products with the environmental factors. So in such a case, always this ultra-processed food items, it will be packed in number 7. For example, you take vermicelli product, you take some wheat milled product. So all these things, it can be easily affected by the environmental factor very quickly. So in such a case, you have to make such a packaging material where the insect should not enter inside the package, where the moisture should not enter, otherwise the gases should not create any changes in the product. So in such a case, the number 7 materials, either co-extruded or laminated materials, which can be used. And another thing, we have that polycarbonate and that nylon. Okay, so these type of products also, which can be used in the packing application, particularly in the vacuum packaging, we are using nylon. For example, packaging of ice cream stored at a lower temperature. Okay, then we can go for polycarbonate. So all these plastic materials which is used in the food applications. So in one example, if you take the milk-based product, so as I told you, the milk-based products are highly perishable. Very quickly, it can be spoiled. Okay, in hours time. Okay, the other product that will stay for 1 or 2 days, but if you take the milk-based product, in hours time, it will change the quality. But this type of products you can see in the market, it can be available in a monolayer material, for example, PET bottle. It is available in a multi-layer or laminated pouches, or it can be available in composite materials. Composite materials, in the sense, it is a combination of flexible with rigid material, or metal can with plastic material. So, like that, different combinations you can get it in the market. So each one will have different kinds of application for different purpose. We have different kinds of packaging materials for the food packing applications. And another thing, we have this polypropylene, this biaxially oriented polypropylene. So in such a case, normally the plastic films, when they produce, they have the machine directions and the transfer directly. When we say biaxially oriented polypropylene, so in both the cases it will be stretched out, so it can have a uniform packing size, the entire film. So this is biaxially oriented polypropylene. So that can be used for packing of the shrink packed commodities. Okay, otherwise if you say that wrapping materials, in all those cases, this BOP will be used, whereas the BOPP film can be used as a particular layer or in the laminated pouches. So these are the things you can have some idea. And another thing, the numbers, as I told you, the 7 numbers, recycling numbers. So once we use the particular food items, next we are throwing the packaging material to the environment. So this packaging material can be collected by different sector people, okay, either municipal people, otherwise waste collecting people. They will collect this packaging material and they will segregate to according to the numbers. So because the individual packaging materials will have different properties, polymer properties in the formation or crystallization or melting. So the temperature will be varying. So in such a case, this according to the number, these plastics will be classified, and that particular plastics will be sent to particular recycling plant, and again it can be formed in a particular shape. But in the food application, so far the plastic material concerned, the one-time used plastics we are not recommending for the second-time usage. For avoiding any resins or any polymers that can easily migrate from the packaging material to the food items, and the recycling unit for the reusable units for the plastics are not completely established like our glass bottle. So in such a case, these plastic bottles usages in the food applications are very less in the current scenario. And there are many people, they are using different kinds of waste utilization purpose. The plastic bottles, considering the environmental friendly, okay, considering the biodegradations, okay, they are using for different applications. And you can see the different designs also available in the market. For example, if I want to drink the sugarcane juice, the packaging material is also available in the form of sugarcane. So when they drink, they will get some similar kinds of appearance. They feel a similar sugarcane, the fresh one they are taking. And another thing, you can have this water can, like 5-liter water cans are coming in the market. Okay, so by using this also you can do some physical exercise. So such a designs are coming. You can use for both the purpose, and you can use the design, that mouthwash. Okay, so you no need to have any measuring cups for every time to have this mouthwash. For example, each turn, if you turn upward direction or downward direction, the known quantity only will comes out, and that can be used for dilution and other purpose. So all these things, according to the consumer convenience, consumer attractions, so only thing you can make very good attractions in the packaging material. So whenever you want to promote your product, always the designing of the packaging material is also will be very important, because many people, they will get training in the making of masala powder, making of some health mix powder. These people, they have very good processing technology, but very less knowledge in the packaging. They will pack it in a normal traditional package, and the people, they will not ready to come and buy such a product. Even though they make very good product, people, they will not buy. So in such a case, you have to balance both the processing and the packaging, so that your product can be easily reach out the consumer market in a bigger way. And when we say some technologies, Okay, so by using this plastic material, one is called this vacuum packaging. Okay, so in this vacuum packaging, what we are doing, we are removing the air from the packet. So this air will be the cause or will be the medium for the microbial contamination, will be the medium for color changes in the product. Okay, so in such a case, oxidation or enzymatic browning, all these things, the air will be the major cause. So in such a case, removal of air from the packet and followed by hermetic sealing. So that is called vacuum packaging. For example, this vacuum packaging done for spices, it can be done for fruits and vegetables, it can be done for nuts. Okay, all in meat, fish, many areas they are using this vacuum packaging. The only thing is we are minimizing the oxygen level inside the package. So because of that minimizing the oxygen level, you are controlling the respiration rate, you are controlling the oxidation reactivity reactions, and you are minimizing the volume of the packet that can support you during the transportation. In all these things, the vacuum packaging is highly recommended. And another thing, in once it is vacuumized, so some of the package product, it has to be after vacuum packaging, it should be stored in the cold storage. Okay, so that majority of the vacuum packed materials, okay, it can be stored in the cold storage so that the shelf life of the commodity, particularly the banana, if you take the shelf life can be extended for 3 months. If you take the cauliflower or something, it can be extended for 1 month to 2 months, 60 days, it can be extended. Cut vegetables, okay, all these things, it can be easily extended by using this vacuum packaging. So the packaging material, either it can be a nylon, otherwise polyamide, or it can be a high density polyethylene, polypropylene. This type of materials are used for vacuum packaging purpose. Another thing, we have modified atmosphere packaging. So whenever we are changing the gas composition inside the packaging material, so that is called modified atmosphere packaging. For example, in our atmosphere, we have 21% of oxygen and 78% of nitrogen and 0.03% of carbon dioxide. So in such a case, when we change this composition level inside the packaging material by minimizing the oxygen level, by increasing the carbon dioxide nitrogen level for supporting the extension of the shelf life commodity, so that is called modified atmosphere packaging. So according to the packaging material what we are using, according to the product characteristics, okay, we are using different kinds of machineries in the MAP. One is called form fill sealing machines, where you have this Lay's or Kurkure packet. So these fried snacks food items, it can be packed in the packaging material, and by filling with nitrogen gas, okay, so the oxidation effect can be controlled. For example, you take the rice. Okay, by filling the rice and carbon dioxide gas, you can control the insect infestation. Okay, so like that, the different gases we are using in the modified atmosphere packaging. Main gases: carbon dioxide, nitrogen, and oxygen. Carbon monoxide. Okay, argon. We are using it, and apart from that, what we can say. Yeah, carbon monoxide, argon, inert gases, okay, then carbon, nitrogen, okay, oxygen, okay, so these gases, helium, okay, these gases we are using it in the food applications, okay, particularly to increase the shelf life of the commodity. Another thing, we have that chamber machines, okay, so in these chamber machines, there may be a trace where the product can be filled and the gases will be flushing into it. Okay, for example, if you take some sweets, Indian sweets or confectionery product, okay, sometimes when we want to improve the shelf life, so the similar kinds of gas composition that can be allowed into the packaging materials in the rigid container that can be used. Otherwise, we can have smoker machines. So, like our vacuum cleaner, what we have at home, a needle can be inserted into the bigger pouch material, particularly packaging of fruits and vegetables, and that can remove the air from the packet, like a passive atmosphere packaging. So that can remove the air from the packet, that can be tightly packed and it can be stored in the cold storage systems. So like that, different kinds of machineries it can be used for creating MAP, the packaging line. Okay, that is called the modifier mode. Another thing, blister packaging. Okay, so when we say that blister packaging, it is a thermoformed packaging material like our pharmaceutical products. Okay, the tablets how we are packaging. Similarly, the blister packaging concepts are also used in the food applications. So the top cover it can be made by PVC material, polyvinyl chloride, and the bottom cover it can be made by the metallized film, or it can be made by the paper with a LDP liner material. And these type of things, it can be supportive to extend the shelf life of the commodity of minimally processed, particularly fresh cut vegetables, that can support you to extend the life for 3 weeks to 4 weeks period under refrigerated conditions. So these coconut cubes can be packed in blister packaging techniques and stored in the cold storage. So whenever we want some cooking purpose of the coconut cubes. So the coconut cubes can be taken from the packet and it can be used for cooking purpose or ready to eat purpose. You can use it like coconut candy or something. Okay, so this is called blister packaging technology. Another thing, we have shrink packaging method. In this shrink packaging method, particularly, we are using some of the packaging material which can be used in the industry at the end-line packaging systems. Okay, so far we have seen primary, secondary packaging material. So this is the shrink packaging is a end-line packaging systems where that unit packaging, individual product packed materials, it can be put it in the secondary packaging material and it can be covered with flexible packaging materials for making bigger size that can be used in the handling and transportations. Okay, so this type of shrink packing materials are made by, for example, polyethylene cover. You can use polypropylene or copolymer of ethylene vinyl acetate. All these things it can be used by using the shrink packaging method. So there is a hot tunnel will be there. So the individual unit packed materials can be put in the carton boxes. It can be covered with flexible packaging material. And when it pass through the hot tunnel, it can be shrink and you will get the packed materials. Okay, so that can be easy for counting and the transportation of these materials. Another plastics what we are using in the grain storage, it is called hermetic packaging. Okay, when we say hermetic packaging, through the packaging material that moisture and gas will not enter. Okay, so here if you see that hermetic bag, either you have that silo bags or you have this multi-layer PP1 bag with the hermetic bags. Okay, always PP1 bag with the LDP liner or gunny bag with the liner, like the different kinds of combinations we have. So this plastic material sometimes it is made by EVOH, ethylene vinyl alcohol. This ethylene vinyl alcohol will have very good properties. For examples, that will not allow the oxygen to enter. So that is the one thing we are using, that ethylene vinyl alcohol. Sometimes this EVOH will be lined with LDP. So when we use this EVOH and the LDP, so the barrier properties will be higher, so that moisture and the gas can be controlled. Okay, so the insect infestations, all these things can be controlled when we go for hermetic packaging. Another area what we are using, edible coating or edible films. So that is also coming in the market. Okay, by using a protein layer, by using a lipid layer, by using a starch film over the valuable commodity. So that also coming in the market, edible coating or edible films in the food packaging applications. When we talk about the fruits and vegetables, okay, so in these fruits and vegetables, this edible coating, for examples, what we can have, the insect-based lipids materials, particularly if you see these honeybee bags, or else if you see some polysaccharide-based coating materials, so that can be applied in the fruits and vegetables, so that can avoid the weight losses, or that can avoid the respirations. Okay, so these are all the things can be done by using this selection of the wax coating material. Another area we are using these active packaging systems, particularly in the processed food items. Either it can be a fruits and vegetables or meat products or dairy products. We are using the active packaging systems. When we say the active packaging systems, the active component, for example, either it can be a gas emitters or it can be a gas absorbers or it can be a the chemical sachets or chemical pad. It can be added into the packaging systems. So that will make the environment that can be suitable for the support of the shelf life extension of the particular commodity. So sometimes they will add the oxygen absorber inside the packaging material. For example, the ferrous iron powder, or you can have that ascorbic acid or that glucose oxidase can be added into the packaging material so that it can absorb that available oxygen. Sometimes they may add the silica gel that can absorb that moisture. Okay, even if you see the jackery, the fungal attack is the major problem in the jackery. Nowadays, you can see in the jackery packaging system, they are using this oxygen absorber as well as silica gel absorber so that the moisture and the oxygen available inside the jackery cubes can be controlled so that the fungal attack can be minimized in the jackery packaging systems. Similarly, for fruits and vegetables, the ethylene absorbers and the cut fruits and vegetables bakery product, we are using ethanol emitters. Okay, there are ethanol emitters by using what we can say ethanol at different concentration inside that packaging material. So what will happen? So that makes the environment, it is antimicrobial environment, so that the microbes cannot be surviving in this environment. Okay. So apart from that, we have the flavor absorbers, we have odor absorbers, we have UV filtered packaging materials. So like, and also you can have the self-heating, self-cooling packaging material. So all these things, we are adding some component into the packaging material that will support you to create some suitable environment for the product so that you can extend the life of this commodity. So these are all things which will be called active packaging material. So you can see some activated charcoal by using potassium permanganate, KMNO4. We can develop own ethylene absorber, and that can be used in the packing of fruits and vegetables so that the ethylene absorptions will be more so that the ripening process can be delayed. That will help you to maintain or extend the shelf life of this type of perishable commodity, particularly fruits where the ethylene production is higher. Sometimes you can give that antimicrobial coating. For example, this antimicrobial coating either it can be organic based, okay, otherwise it can be a herbal extract, it can be essential oil, okay, otherwise it can be a fungicidal, any antibacterial materials, coating material can be applied on the product, otherwise inside the packaging material. So that will also make the environment where the bacterial attack or fungal growth can be minimized. Particularly if you take that potato and onion, that sprouting inhibitions also can be done by creating such a coating material inside the packaging material, so that can be controlled. So some people, when we apply the coating material on the commodity, okay, so they will have some concern on it. Either when we consume this coating material, either there may be any health issues or not. So in such a case, to avoid those things, it can be given inner the packaging material coating. So that also will support you. Always this active component can be added in the sachet or pad, can be added in the packaging material. So that will also will have very good active packaging function. We have this self-heating, self-cooling purpose. Both are working on the mechanisms like endothermic and exothermic reactions. So sometimes the heat will be emitted, sometimes the heat will be absorbed. That is the case. For example, if you take that self-heating, they will use calcium hydroxide with the water, that chemical reactions will be there that will generate heat. When we want to create the cooling effect, they will have cooling glycol with water, so that will absorb the heat from the product. So that the mechanisms will be differ, but this type of examples it is for the active packaging system. So to satisfy the consumers, so these type of things also can be created. But when the limitations, if you see, The recycling is the problem because when we go for this type of self-heating and self-cooling can, we have multi-wall material, multi-wall packaging material to avoid the chemical reactions with the food items. And only it should have very good heat transfer. The package material should have the very good heat transfer so that the heat can be easily transferred to the inner food material, or inner food material heat can be easily absorbed by the outside medium. So you have to select the packaging material, it should have very good heat transfer effect, and also there should not be any chemical reactions. That is the case. Even there are many institutions that are working on R&D, creating such a active packaging with lesser cost. Even if you create, there are many industries are ready to take this technology for their usages. Another packaging materials what we have is a paper. In this paper, mainly that craft paper, parchment paper, and wax paper. These are all the things that can be used in the food applications for the direct tunnel purpose. Particularly the processed grease proofs and parchment papers are used in the bakery items, or it can be used in the dairy products for packing of valuable commodity. That craft paper, it can be used with a liner for packaging of grocery materials, and once it is used and it can be thrown away, and these collected waste materials can be used for recycle the paper board material. Okay, so corrugated fiber board boxes. In that manufacturing, it can be used. Okay. So these corrugated fiber board boxes, it is available in different shapes and size also for different food applications, for packaging of fruits and vegetables, packaging of grocery food items, packaging of finishable food products. For all the cases, these cardboard or corrugated fiber board boxes are used. It's also available in a number of liners and flute layers. Okay. Whenever we want to export the commodity, so in such a case, even if you want some idea about the packaging material regarding the dimension, size, okay, so you can download from the APIDA website. So in that APIDA website, they given export standard packaging requirements for different commodities. For example, if you take packaging requirement for export purpose in the mango or potato, even you can take grapes, okay, apple, all these things they given the standards. Okay, what is the packet size? What is the number of liners? What is the number of tubes? What is the perforation diameter of the holes in the corrugated boxes? The number of perforations. All these things it has been given, and that document you can take it for reference purpose. And similar kinds of packaging material you can make it in the local industry, and that can be used for the packing purpose. Okay, so these are some dimensions, and you can have these composite containers also. The packaging material, for example, minimizing the usage of the plastics, we are using this type of composite container. In these composite containers, so here these things you can see it's a complete plastic containers. So here you can see composite containers. So it is made by the thick cardboard material, and it is covered with the inner aluminum foil material, and the top and bottom it is covered with metal lids, otherwise it can be covered with plastic lids. So in such a case, the usage of plastics in these composite containers can be minimized, environmental friendly, and it is also having a recyclable properties. Again, you can create such a containers. And another thing, the cost of these packaging materials also lesser. So these type of things, innovations are coming in the minimizing the usage of plastics in the paper and paper-based materials. Another thing, you have bag in box systems. Okay, so here also you can have the bag. Okay, inside you have pouch material which can be filled with the product, and this material is the primary packaging material, will have very good gas barrier and moisture barrier, and this material it can be put it in the box. Okay, it is made by the cardboard material, paper based material, and it can be kept in the market shelves in the stand up method, and also will have very good printing ability. You can make what we can say good visibility to the consumers, and it has a very good printing properties. So those things it can be done in the outside the secondary packaging materials. For example, any health mix powder. if you take any dairy products, okay, so sometimes the valuable commodity, it can be bakery product, can be packed in the pouches, and it can be put it in the boxes, cardboard boxes. Okay, this type of things is used called bagging box method. Fruit juice industry, oil industry, many industry they are using this bagging box method. Another thing, metal containers. So this is also used in the food application, particularly thermally processed food items. When we use retard-based technology for extending the commodity for 6 months and 1 year, we are using metal can packaging. So these metal cans, it is available in the foil, aluminum foil. It is available in container. Either it can be a cylindrical container or it can be a cubical ships. So we have aluminum cans, tin-free steel cans, tin cans. Okay, so like that, three different cans can be used. Okay, the tin can be applied on the packaging material by using electrolytic OPM technology. And different cans, tin cans, aluminum cans, it can be used for different purposes. For example, if you see that carbonated beverages, it can be packed in aluminum cans. If it is a thermally processed food items, it is packed in tin-free steel cans or tin cans, particularly the coconut milk is packed in tin-free steel cans. If you take slice the pineapple, green peas, okay, cut fruits and vegetables, meat items, all these things are packed in tin containers. And these containers are available either in the form of 2 piece or 3 piece. So there may be a 2 lid and 1 body portion will be there. Otherwise, 1 body portion and 1 lid will be there. This is called 2 piece and 3 piece can. This 2 piece also it can be made by that drawn and redrawn method. Okay. And here you can see as I told you, the aluminum foil, the tins are little bit thicker, then you can make such tube forms. Okay, so there are some food items, particularly if you take that turmeric paste, ginger paste, you take tamarind paste. So these are all things apart from pouch material. These also coming in the form of tubes, metal tube. Okay, in a highly concentrated form. So that what will happen? The barrier properties can be increased. The usage can also be controlled. Okay, the delivery systems you can control it. So these are the methods we are using. This scanning process will have starting from collection of raw material, blanching, processing the food items, then it can be filled in the particular containers, and keeping this product in the elevated temperature. For example, in the retard chamber, as I told you, maximum they will go for 121.1 degrees centigrade with a different time intervals based on the microbial load. So either 1 hour or 20 minutes or 30 minutes heating time. So in this case, what will happen? The microbial load can be minimized. The maximum will be 12D log reductions. Sometimes it can be 2D or 5D log reductions will be there. In such a case, these products can be stayed in the open atmosphere. After retarding, it can stay in the open atmosphere, and that can be extended the life for 6 months or 1 year. Okay? So there are many products, canned mushroom, canned tomato paste, okay, soup powder, green peas, cut vegetables, meat items, all these things you can get it in the market. Whenever you use these canned food items, particularly in the PMFME scheme, to set the canning industry, if you have some 25 lakhs, you can set a very good can processing in the canning industry. And these are all other machineries. Okay, for example, can breeder, okay, can seamer, exhausting unit, all are other accessories machines for canning of food items. And these setups all they include some 25 lakhs, 30 lakhs. You can have very good canning unit. And also you have aerosol packaging, okay, in the form of foamed materials. Okay, the products can be filled in the containers, and it can be ready to eat or ready to serve. Okay, for example, some seasoning purpose or sometimes for edible purpose, that coffee foam or milk cream. Okay, it can be packed in the aerosol packaging. Even you can see chili spray. Okay, the spice extract it can be filled in the aerosol packaging method. so that we can use it for different food applications, soup preparations, or some coffee cappuccino or some coffee, cold coffee, in those areas that milk cream directly can be applied on the product. Okay, so this the propellants what they are using, the actuator, okay, that valve systems. So all these designs are very important when we go for this designing the aerosol packaging. This also will have very good shell, but sometimes the nitrogen gas can be used as a propellants. Okay, otherwise some propylene gas. Okay, so that also will be used as a propellants that can create the gas pressure inside the containers. Then we have glass bottle. Okay, that glass bottles, the first packaging materials after that Stone Age, what we use is the glass material starting from the Egyptian age. So there are many innovations has been taking place in the glass packaging material. Nowadays, you can see in the market the frosted glass also coming in the market. Okay, to make very good appeal or appearance for the consumers. Okay, the particularly see alcoholic beverages. Okay, so it is packed in the frosted glass. Okay, like an opaque color. You can see the internal product color directly. So, but you will have some color values of the frosted glass. Okay, that is huge. And the different shapes are also available. In general, the glass bottles, wider mouth and narrow mouth glass bottles are used. It can be produced in the industry by press and blow method or blow and blow method. Okay. Even sometimes the glass bottle it can be affected by the UV rays. So in such a case, UV protected amber glass are used in the packing application. Normally, type 1, 2, 3, 4 types we are using for the food application. It's based on the silica content, based on that what we can say the coloring agents, what we are adding magnesium oxide. Whereas we are using that iron oxide in the glass manufacturing process. Okay, alum content. So the type 1, type 2 will be varied. Okay, so 2 and 3 we are using in the packaging of that carbonated beverages and other glass bottles. Here one example just in the USA there is a company which is called Nantucket Nectar. This glass bottle manufacturing in the packaging industry, the labeling of packaging designs. Okay, the people they will buy the product by the attraction of this packaging materials itself. For example, the labels. If you take the apple juice, or if you take the pomegranate juice, or if you take the berry fruits juice. Okay, so in such a case, the labeling also will similar colors of that product, original color. Okay, for example, you take the cut pieces of the apple and the juice color will be the same. And also when the people drink the juice, okay, nowadays many people they will use mobile phones when they drink something. Okay, they will see the messages, but those people they have some information they are giving inside the labels. Okay, when they open the brochures, they have some general knowledge questions so that it can be make some relaxations when they feel drinking this material. Nowadays, these PET bottle, transparent PET bottles are also coming in the carbonated beverages. Okay, so that the people they can see that they are in colors. That, for example, fruit extract added beverages are coming in the carbonated beverages. Those things also some new kinds of innovations coming in the market, so that the industry can use it for making available such a innovative technology for promoting the brands in the market. Edible oils. Okay, the edible oils you can see either it can be unit packaging or bulk packaging, either it can be flexible containers or rigid container. We are using in butterfly wall, different ergonomically designed the glass bottles or the plastic containers are used for oil because it has the slippery nature that oil bottles to maintain a grip. There are different shapes they are using. Even sometimes that is edible oil, gelatin tubes. Okay, that can capsulated oils and also, for example, omega-3 fatty acid, fish oils. Okay, all these things are coming in the gelatin tube based, so it can be directly consumed. So in all these cases, when we use the plastics in the packing application, the FFSS is The PVC migration should be lesser than 0.1 ppm, polystyrene 0.2 ppm, polyacrylonitrile 11 ppm, nylon, polyamide 6 to 10 ppm, which should be lesser than that. So if it is more than that, then actually the product packaging materials cannot be considered. It is often. So these migration levels, it can be even with particular standards. So that we have to follow when we go for packaging of this edible oil. Okay. Then this multi-layer materials, particularly for the processed food items, these multi-layer materials in the form of tube or sachet we are using, particularly highly perishable commodities. Okay, so that can be packed in this multi-layer material so that the product life can be extended for 3 months under normal storage condition. But this type of product, once it is open, it should be packed in, it should be stored in the refrigerator conditions, and they will say minimum within 5 days or within 1 week period it has to be utilized. So this type of things also you have to be considered when we handle this product. And then we have the tetra packing technology for the fruit juices milk. Okay, so it has different layers, mainly 6 to above 6 lines will be there. So it can be used for thermally processed food items or ultra high processed food items. We are using this tetra packaging technology. So this packaging material sometimes it is available recyclable. Okay, so some of the materials less in weight, so many people they can easily carry, and that can supplement the sufficient nutrition, energy to different kinds of peoples in our country. And there are different kinds of filling equipments are available. So either it can be filled by the weight basis, or it can be filled by the unit basis, or it can be filled by the volume basis. We have different kinds of filling equipments, and there are different mechanisms. Either it can be a pedal operated, hand operated, or it can be automatic operated. Okay, so like that, different mechanisms are used for the different kinds of filling equipments. And we have general form feed sealing machines for the packing of powder and for the packing of granular materials or the flakes material. So this form feed sealing materials it is available in terms of auger filling method, in terms of cup filling method, in terms of vibratory filler method. So according to the product, okay, so either the potato chips can be filled in your pouches, then they may go for vibratory filler, or can be go for bucket conveyor type of filling mechanisms. If it is a masala powder, it is a auger filling method. Okay, it's a granular material, they will come for cup filling method. According to the filling methods, either it may be a vertical form fill sealing machine, or it can be horizontal form fill sealing machines it can be used. Okay, these are other type of sealing machines, induction sealing, cap closures, bottle curtain, van sealer, impulse sealer, box sealer. So these are all the machines are available starting from the tabletop to the industrial bigger applications. It can be a continuous packing or batch sealing for different kinds of applications. It can be used even starting from 10,000 rupees to 4 lakhs, 5 lakhs rupees. Bigger machines are available. For example, if you take that band sealer, okay, in this band sealer nowadays, gas flushing band sealer also will be there. So it will allow the nitrogen gas to fill into the pouches, then the sealing can be done. So like that, impulse sealer with the gas flushing, band sealer with the gas flushing, tabletop, okay, hand operated. So like that, different kinds, different size will be available in the market. Another thing, N pack, okay, and the packaging industry under N, we will use this type of packing equipment for proper arrangement of packaging systems during the transportation, during the storage environment, the warehouses. We will use this type of packaging material, either case rectors. So that will make such a corrugated box that will make in a particular shapes. Then we have gas sealers, palletizing robotic type of palletizing equipment, and sleeve wrappers. So these are all the equipments used in the N-pack line, okay, for the packaging of commodity in the industry. Another 5 minutes we will complete, okay. So next thing is intelligent packaging, okay. They will call smart packaging also. The active packaging, they will add some of the active component inside the package that make the environment. But when we say intelligent packaging, that will protect the food items from the environmental factors. At the same time, it will monitor the quality of the internal quality of the product, and it can be communicated to the consumers. So these type of packaging systems are also coming in the market. It is called intelligent packaging. Either they may use freshness indicators, gas indicators, microbial indicators, gas indicators, okay, temperature indicator, thermographic inks can be used, temperature indicator. So like that, different kinds of indicators or sensors, it can be used in the packaging material that can regularly monitor the quality of the product, that can communicate to the industry people, particularly in the traceability, and that can communicate to the consumers regarding the product quality. Tamper evidence packaging materials, okay, that is cellophane tapes, okay, that ancillary materials, okay, making the cellophane tape with particular packing materials, okay, so that will make more strength. So you can't easily open the packaging materials until if you make damages in the and in the material. So that will safeguard your product, and that will avoid the adulteration, okay, mishandling of your packed product in the market, in the supply chain. So these type of anti-theft tampering evidence packaging materials are also coming in the market. RFID tags, radio frequency tags, whether it can be a QR code, hashtag code, the barcoding systems that can be used to easily trace the product, trace the shipping methods of your product. Otherwise, that can give more information because all the content we can print on the packaging material. So some of the things it can be given in the QR code system so that when they scan it, they can get more information about the product apart from the information available in the printed labels. So these are all the technology. Nowadays, it is used to the high value commodities, particularly you can take that virgin coconut oil, okay? Otherwise, you can take some of the alcoholic beverages. Otherwise, you can take some of the commodity the company will give offer, okay? So those things it can be scanned by using this QR coding system. Now another technology, laser labeling. Okay, so here we don't want to print, we don't want any labels. Directly I want to print my content on the product. So in such a case, that laser labeling techniques are used. So in such a case, the products, particularly the fruits and vegetables, will have very hard surfaces. If you take coconut, if you take pumpkin, okay. So in those commodities, the surfaces will be hard, and these laser labeling techniques can be used for labeling purpose in those commodities, because when you go for laser labeling, some amount of heat can be generated. So plastic material we can do this laser labeling technology. So the materials which can withstand the temperature that cannot be easily deformed by this laser heating. So those materials can be used for laser labeling techniques. Nanotechnology, particularly nano sensor, nano composite materials, nano filters, all these things are also used in the packaging line for improving the barrier properties, for improving the antibacterial effect, okay, by improving the active packaging system that allowing particular gases or particular absorbing particular gases by using the nano fibers or nanofiller materials. So this nanotechnology area also is used in the packaging applications. Many nano pack products are used in the oil packaging, bread packaging, fruits and vegetable, particularly my fresh cut fruits and vegetable packaging. Okay, these bakery products, these nano packaging technologies are used. Edible packaging is another area nowadays which is coming in the market. Okay, for minimizing the usage of the plastics, this edible cutlery, edible tableware. Okay, so these are all the materials are coming. Many institutions are working on it. Even from Tanjavur, we are working on developing edible cutlery-based packaging material from agriculture and the food industry waste. Okay, so this we have developed that edible cutlery from coconut wood powder. We developed the packaging material from what we can say that mango seed kernels. We developed the packaging material from the jackfruit peel waste. So like that, different agriculture processing industry waste can be converted into the packaging. Another area we are now currently working on, many packaging industries are using this bioplastic packaging materials. You can see that edible balls, okay, that easily biodegradable packaging material, polylactic acid, PHA, PHP. these bioplastic materials are also used in the packaging industry. When compared to conventional packaging materials, these biopackaging materials will have less barrier in the gases and the moisture. So by adding, by improving the molecular weight, by improving that the different polymers, bio-based polymers into the structures, the barrier properties can be increased. So, for example, if you take the polylactic acid based packaging materials in the form of flexible or rigid containers, it is used in the different food applications. Okay. So, the other thing, and there are novel technologies, the flowering tea bags. Okay. Packaging materials will have the content when you put it in hot water, that makes the difference in the shapes, that makes the availability of the green teas, okay, in the water, okay, so that makes the mind freshness and it can be uh, the particular flavor can be added in the particular packing materials. These are all the things are coming in the market, different innovative area, the packaging line. The labeling is another area. Whenever we say that food labeling, as per the FSSAI standards, the labeling requirements also the food industry has to fulfill. So in such a case, we are using different kinds of certifying um, uh, methods. For example, FSSAI, halal certifications, okay, the Bureau of Indian Standards, DOCMAR, AS standards, all these things we are using, particularly concerning the food item that FSSAI we are using the beer way. So in such a case, what is the logo you are making? What is the brand name you are giving? So they are giving some 16 parameters. It has to be printed on the packaging material, and they given what is the dimension of those things printed material also. So according to the standards only, according to the projected area of the packaging material, we have to print the content on the packaging material to avoid the misleading or misguidance to the consumers in the market. So in such a case, for example, when we say the FSSAI labeling, the important thing is the manufacture date and the expiry date. As a food industry, we know what is the manufacturing date of our product, but the expiry date we could not easily tell until otherwise if you do some experiment with the support of some research institution or with a laboratory. So in such a case, the expiry date of this commodity can be easily calculated by literature study method or TAN over time, endpoint strain method or accelerated shelf life testing method. So in many of the food industries, they may use this ASLT method by keeping the product at different elevated temperatures, different relatability, the different kinds of packaging material, and they will evaluate the shelf life based on the quality changes. They will evaluate the shelf life based on that. By selecting a suitable models, they can predict what will be the expected shelf life of the commodity. So once you calculated the expiry date, that can be put it in the packaging material so that it can be fulfill the requirement of FSSAI. As a learner and say industry people, we must get more knowledge or more information in the FSSAI website. So if you see that the food product standards regulations, this 2011 and 2018, the downloaded documents are available in the Google in the FSSAI website. So they given there are some 12 products. There are different kinds of products for the packaging and labeling requirements, starting from dairy product to irradiated food items. For all these things, they given what are the kinds of packaging material and standard they are following, what is the migration limits, and what are the things should be avoided in the labeling, okay, misleading. All these things, the information has been given. So in such a case, as a master trainer, any particular area, if you want to get more information, the particular document when you go through some 3 to 4 pages for the individual product they given. So that will give the overall idea. Otherwise, our government policies, the FSSAI policies in the application of the food packaging and labeling requirements. So these are all the minimum what we can say the requirements as per the recommendation of FSSAI, all these things it has to be printed. Okay, it will be varying with the product types of product what we are using it, and sometimes the storage information and the preparation information that also will be given in the packaging material for the consumers to understand after opening where to be stored, okay, how to process it, everything it has to be given. With this informations, overall information about the packaging technology, the packaging machineries and materials, I just want to conclude. For example, let's say industry peoples and as well as the technicians and the researchers. So far, we are seeing many packaging materials when we enter the supermarket. When we buy any product, we are having some kinds of packaging material which is used for in the food applications. But now I request you, everybody, when you buy any materials, you just go through the content. You get some information which is printed on the packaging material. So based on that also you can train or you can give the transfer the knowledge to the follow for the trainers to get any idea on the packaging material. And also you can tell them whenever they select the packaging material, that packaging material after purchasing or before purchasing, it has to be given to some testing center to understand the purchased material will have the similar properties as per the supplier. So in such a case, there are many NABL aggregated labs are available in the country. Even NIPTM Tanjavur, we have NABL testing center for the mechanical testing of the packaging material. And also we have a separate department for the testing of packaging material. So you can send the samples for testing of WVG and water vapor transmission rate, gas welding, okay, and also migration. All these things we can also do. We can also certify it. So that can be supportive to the industry people. They are packing the product in very good packaging material. And another thing, whenever you select the packaging material, you tell them the cost of the packaging material should be reasonable, and also if you see the recyclability or environmental friendly packaging material, so that can be easily recommended for the end users or the industry people, so that can support the industries as well as the consumers environment. These are the things, something you can consider when you advise the trainees or when you recommend some packaging material to some people. So these are the things should be considered. With this, I thank the organizer PMFM meeting, our beloved directors for giving this opportunity to share some of the idea or technology which is available in the current packaging scenarios. So thank you very much.
Thank you so much, sir, for such an elaborative presentation. And it's, I think participants understand what you are talking about the packaging. So
Okay.
one question is there. For tea drinking, plastic.
Can you louder, please?
For tea drinking,
Tea.
tea.
Ah.
Plastic cups and paper cups are used,
Hmm.
but people are saying that some polymers are releasing during hot material, uh, and that cause cancer. Please
Yes, yes.
please explain about this. And plastic polymers can react with food nutrients during the pasteurization of food and food packaging materials. Please
Yes.
explain.
Yes. You know, the tea bags, tea they are serving in the paper cups. These paper cups inside will be lined with LDP materials. Now, these paper cups, now it is banned by many states. Even the government, they are not recommending these paper cups for the what we can say the tea. Even sometimes inner liner will be that LDP material. Sometimes that wax coated papers will be there. Okay, so the lipids will melt when we serve the hot beverages. So in such a case, it was not recommended nowadays. It is not recommended nowadays serving the tea in the paper cups. Okay, and another thing, when we go for the plastics, particularly and the pasteurization purpose, For example, when we say the pasteurization, it is having a different kinds of technology. For example, you can keep the temperature 60 degrees centigrade for 20 minutes or 30 minutes, or you can keep the product 75 degrees centigrade for 5 minutes or 15 minutes. So the time and the temperature will be varying according to the pasteurization methods. So in such a case, this pasteurized product, after cooling, it can be packed inside the PET containers by using this aseptic packaging method, so that the heat will not have any impact with the plastic material. Some plastic material, for example, if you go for hot filling, for example, when we go for heating the product and you bring down the product temperature to lower, something like 35 degree, 40 degree, then if it is packed in PET bottles or something, okay, then again it can be kept in the hot water. So in such a case, when you select such a packaging materials, if you take the PET bottles, okay, it has some thermal melting point, okay, it will be around 120 degree or above 100 degrees, that heating temperature. So it can't form very quickly. Otherwise, it can be heated and immediately it will be cooled. It can bring down to lower temperature. So in such a case, the thermal stability of that plastic materials in terms of plastic deformations or in terms of that chemical migrations, it has to be understood, so that you can avoid this type of misleading in the processing line. Normally, when we use the PET bottle in the processing line, the processed pasteurized product, after pasteurization, it can be cooled down to atmospheric temperature, it can be cooled down to lower temperature, then it will be filled in the PET containers, particularly that carbonated beverages, or if you take the fruit juices in the PET bottle filling line. So normally the juice items, it will be filled in the lower temperature in the PET bottle. So you will not get any chemical migrations in the normal atmospheric temperature, 30 degree or 32 degree, after filling or after packaging when we keep it in the normal atmosphere. But this material, when it is exposed to long under the temperate conditions, otherwise when it is exposed to sunlight for the longer period, so then there may be a leaching or diffusion of some polymers into the product. So these packed food items, PET bottle packed food items, it should be stored in the shaded area in the dark place, so that any plastic migrations, all these things can be controlled as per the recommendations of the shelf life 6 months or 3 months. It can be controlled. Yes.
So one more question. What is the most efficient packaging for fruits and vegetables in India?
Efficient packaging material, easy friendly packaging materials will be the plastic based materials. For example, this polyethylene, okay, that high density polyethylene or polypropylene or polyamide, nylon. Okay, so these are all the flexible packaging materials are used for fresh cut fruits and vegetables. If you go for MAP, then you should have gas barrier material, laminated pouches will have very good gas barrier for nitrogen, carbon dioxide. Okay, so that the MAP based packaging material. Even you see that dried fruits, okay, dried nuts, okay, it can be also packed in a vacuum packaging system. So in such a case, when you go for such a vacuum packaging system, your packaging material should have very good flexibility. Okay, according to the product shapes, it should be shrink. Okay, and when we go for dried fruits and vegetables, sometimes the sharp edges, when we go for vacuum packaging, that make puncture in the flexible material, that will give air diffusion. So the packaging material should have very good puncture resistance and also very good flexibility in nature, so that it can very easily shrink, and that will not allow any gases which will enter oxygen, particularly during the storage period, so that you can avoid that oxidation effect in the dried commodity. So plastic based materials are more friendly used in the fruits and vegetables area for packing purpose. If it is a thermal stable, okay, 6 months, 1 year you want to pack, then canned pineapple or canned peas, then you can have retard packaging systems, okay, for ready to eat or ready to cook product, vegetable gravy or something. Then you can go for metal retard packaging systems. So these two methods it is used. Yes.
So one more question. Difference between co-extrusion technology and lamination, which is better for food?
One more time.
Difference between co-extrusion technology and lamination, which is better for food?
Yeah, for example, the processing methods will be different. For example, co-extrusion technology, there are three extruders. For example, from one extruder, okay, when we make the axial blown film forming process, from one extruder, one polymer, for example, high density polyethylene will come. From another co-extruder, okay, that polyethylene terephthalate will come in another extruder, for example, EVOV. Okay, so like that, from three extruded, the individual mono material will come, and that can have the mixing in the film forming area, and the sheet can be formed. So this is a method which will be called extrusion process. When we say lamination process, so there may be a from one extruder the film can be formed. For example, in a casting method, the polyethylene layers can be formed from one method. In another method, that polypropylene or that aluminum foil film can be made. Now, the merging of or the joining of these two different layers by using some heat treatment or by using some adhesive material, the two films can be joined. That is called a lamination process. So this is according to the manufacturing process, the layers can be formation will be different. Either it can be a co-extruded material or it can be a laminated film. And when we make some rigid containers, these co-extruded films are used. Whenever we make flexible materials, laminated forms, films are made by using the lamination technologies. So this is the methods which can be used for making flexible or rigid containers. And there is a difference in the manufacturing methods. Okay, so what thickness? Either you are using 5 micron of LDPE, 15 micron of metallized film, and 3 micron of or 7 micron of outer PET. So like that, it is a lamination method they can make. Okay. So in other case, when we make some PET containers or rigid containers, then they may use that co-extrusion technology for making this type of the closures containers. That is called the extrusion technology.
So one more question. How changing the orientation of PP affects its characteristics?
What now?
How changing the orientation of PP affects its characteristics?
Changing orientation, as I told you, that biaxially oriented polypropylene, isn't it? You will say BOPP line, particularly in the polypropylene. So normally in the polypropylene, for examples, if you see from the industry, high density polyethylene, if you take the film forming properties in the industry by using axial blown method, the high density polyethylene, the extruder will release the polymer at the lower section, then the blown can be done, and finally by using passing through the different molars, they will get the sheet. Okay, but if you see in the polyethylene, it will come from the top, it will be collected in the bottom. Okay, the rollers will be done in the bottom. So here they will use the what we can say the air and the diameter ratio, pressure and diameter ratio for making the films. So in such a films we'll have one is that the machine directions, one will be in the transfer direction. So any film you take, you can see according to the film formation, that movement, we have that machine directions, the cross direction will be there. In biaxially oriented polypropylene, in the both things will be switched down. Okay, so you will get what we can have. You can't easily find out which one will be the machine direction, which one will be the transverse direction, because it seems to be the uniformly spread out. that packaging materials. So you can't get the differences which those things. And similarly, these type of materials, when we go for that MAP tray packing, or when we go for MAP tray sealing, or when we go for the shrink wrapping, so that what will happen, it can be easily attractive by the surface material, so that you will not get any differences. Okay, so it can be easily fit into the product surfaces, so that it can have the very good transparency. You can see, because both the sides stitched out, so that it has very good transparency than what we have the existing polypropylene material, and also the shrinkable characteristics that can support you. It can orient with the product natures. Okay, there will not be any ups and downs. It can fit into the product surface, because our agriculture materials are irregular in shapes. Okay, so that the materials can be easily fit into the surfaces, so that it can avoid any dust depositions, or it can avoid any interaction with the environment very easily when we go for shrink packaging product. So that is the advantages we have with the BOPP. Even sometimes the inner liner, okay, it can be made by the BOPP materials. As we told, the grocery materials, pulses, or the grinds, it can be packed in a BOPP liner based paper material. Okay, so inner lining will be the BOPP, so it has more transparency. Easily you can see about the product. Okay, more visibility you can get it. So these are all the things that can be done by the BOPP materials. Yeah.
Thank you so much, sir.